We're working with the Pythagorean theorem. Pythagorean theorem only applies to right triangles. We're being asked to find the exact length of the third side here. All right, so it's really good to kind of label these and get things out that you need to. So Pythagorean theorem, what's the Pythagorean theorem? A squared plus b squared equals c squared. And it's really important that the c always has to be the hypotenuse, Hypotenuse. The hypotenuse, it's the longest side. It's always opposite the right angle. So the hypotenuse is this one right here. That's the hype. All right. All right, in this case, we're just calling it C though. So it's real important that we just practice the hypotenuse vocabulary. And then A and B doesn't matter which one's which. So they're both legs. Those are arbitrary. It doesn't matter. So I'll call this one A and I'll call this one B. All right, so then we just plug everything in. So A in this context is what we're looking for. Plus B is 24. We're squaring that, and that equals C. C is 26, and then we square that. Okay, then we'll go ahead and use a calculator to kind of help us get through these big numbers. So 24 times 24 and 26 times 26. All right, so that gives me a squared plus 576, it's 24 squared, equals 676. All right, now to get A by itself, we'll go ahead and just subtract 576 from both sides. And that gives us minus 576, 100. All right, and how do we undo a square? How do we get A by itself? What keeps 8 from being by itself? The square. How do we get rid of it? The opposite of square is square root. But it's really important. Do you remember what Sanders always says about undoing an even power or undoing a square? Always have to remember what? There's a plus and minus on these. Now, since we are in length is always positive, so we drop the minus sign at this point, but it's really important just to have that written down because that's part of the problem. So that's A equals, we drop the minus sign because we're talking about a length, the square root of 100 is 10, and there's our answer. Okay. As always, just kind of look through it, make sure they wrote down the formula too. That's what we're supposed to do. And then just do the steps. Good. Let's take a look at the different types of problems we have here. All right. What should we do first? We have a formula. We should write it down. Pythagorean theorem. You need to memorize that if you don't have it memorized already. And then what is it that we have to remember? That C is always it has to be the hype. All right. So this side has to be the C. That's the one we're looking for. Doesn't matter which one's which. I'll go ahead and call this one B this time. Doesn't matter. Called it A last time. They're legs. They're interchangeable. It doesn't matter which one's which. C is the one that matters. All right, so plugging things in. A is 11 squared plus B is 60 squared equals C is what we're looking for. Okay, calculator, 11 squared. I should have known that, 121. 60 squared, let's go ahead and practice this. 3, 6, and 2 zeros equals C squared. So I can 3, 7, 2, 1 is equal to C squared. And how do we get c by itself? We undo the square. How do we undo a square? Square root. What did I tell you to always have when you undo a square or an even power? What am I forgetting? The plus and minus sign. Then we use logic to drop the minus sign. Okay, but we always want to practice writing it. So c is equal to the square root of 3721. So on my calculator, let's see if that's a real number or a whole number. 3721 and 61 is the answer. Make sure you're practicing with your calculator too, whatever calculator you're using. You need to be able to do these with your technology too. And nothing strange going on here. Okay. A squared plus b squared equals c squared. C has to be the hypotenuse. This is c. I'll call this a. I'll call this b. So that would be 6 squared plus 2 squared equals c squared. Always write it out. 36 plus 40 4 equals c squared. 40 equals c squared. Square root. What did I forget? On purpose, the plus and minus. Remember, keep practicing that. So there is no square root of 40. I know this one well enough. But I do want to see how 40 breaks down. Now, so what we do is I use a prime factorization. So here's my 40. I break down 40 into all of its primes. And then, so let me first, we're talking about c is equal to square root of 40. And then we have to simplify the 40. So 40 is really 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. All right, so that's the prime factorization. So c is really equal to the square root of 2 times 2 times 2 times 5. Now, my trick is I pull out pairs. So there's a pair of 2's here. It comes out as one number. So this is equal to c is equal to 2 radical. What's left inside? 2 times 5 is 10. All right, so that's the trick. That's an ugly 2, but it's a 2. All right, so the trick is you break it down to the prime factors, and then you pull out any pairs as a single number. Answer 2 radical 10. Yep. They're keeping it as square root of 40, but at this level, you need to practice pulling out your pairs and simplifying your radical. So notice they gave me an okay, even though it's not exactly. All right. Find leg, rounded radical. So the last type of problem that you'll see here, the finding the leg using this technique is exactly the same as we saw. The last one is this rounding technique. All right, and to find the leg, so we'll go ahead and just do it the same way. A squared plus b squared equals c squared. Write down the Pythagorean theorem. C has to be the hypotenuse, so mark that right away. I'll call this A. I'm looking for B then. So A is 3 squared, excuse me, plus our B squared equals C is 7. That gets squared. So that's 9 plus B squared equals 49. Minus 9, we got that same number again. So all the steps are exactly the same on this. Drop the minus, factor it out, prime factorization, all that, 2 radical 10. All right. All the problems are going to be similar to the ones we've just seen with minor variations. Okay, good luck on these. Oh, let's see. 9 minus 49 is 40. Oh, Sanders, you're not reading it very good. Nearest tenth. So that means I would take my calculator. I'm just I guess I'm rushing through it too much. Sorry about that. So square root of 40. Not the same as the last one I just did. Careful. Always read the direction. Find what? The length of the third side. Nearest tenth. All right. So square root of 40 is equal to, on my calculator, I got 6.324 ... goes on forever. Nearest tenth is this number right here. I look to the hundredths place, which is the next one. That's a 2, so it drops off. We use the approximation equal sign. 6.3. 6.3, and there we are. So the rest of them are the same. Just kind of be careful. I gave the exact solution. They wanted the rounded one.